If you stood on a stone bridge in the 1870s, somewhere along the rivers of Europe or the industrial valleys of America, the world beneath your feet would have felt different. Not simply old, not simply solid, but permanent in a way modern structures never achieve. The arches curved with precision that seemed grown rather than built. Travelers often paused midway, compelled to touch railings they could not explain. Engineers measured these structures and found their calculations didn't match. The spans were too wide, the foundations too deep, the craftsmanship too perfect, and nowhere could anyone find a clear account of how they were built. By the mid-1800s, across the expanding cities of Europe and the raw industrial towns of America, engineers encountered a problem they rarely discussed in public. The bridges they were asked to inspect, to repair, to occasionally condemn, did not match anything in their training. These were not the crude timber crossings of frontier settlements. These were not the simple stone arches of medieval villages. These were structures of a different order entirely. Something about them felt wrong, not damaged, not dangerous. Simply impossible, according to everything the engineers thought they knew. Surveyors sent to assess bridge conditions returned with reports full of contradictions. One engineer in Pennsylvania wrote that he had measured a stone arch spanning nearly 200 feet across a river gorge. The stones fit so precisely that he could not insert a knife blade between them. There was no visible mortar. There were no iron clamps holding anything together. The arch simply held, as if the stones had been carved to lock together, like pieces of a puzzle designed by someone who understood weight and pressure in ways his textbooks did not cover. He spent 3 days examining the structure. He filled 2 notebooks with measurements, and he concluded his report with a confession. He could not explain what he was looking at. Another report from Bavaria described an iron bridge with supports that showed no weld marks, no rivets, no bolts. The iron appeared to have been cast as a single continuous piece, despite spanning over 300 feet. The surveyor noted that modern foundries could not produce iron in those dimensions. He assumed the bridge must have been assembled from smaller sections joined with exceptional skill. But when he examined the joints under magnification, he found nothing. No seams, no patches, no evidence of assembly at all. The iron flowed from one section to the next as if it had always been one piece, as if it had been poured into place by giants and allowed to cool over centuries. These reports accumulated quietly in municipal archives, in university libraries, in the private collections of engineering societies. Few were published. Fewer still were discussed openly. The official position was simple. The bridges were old, the records incomplete. The original builders merely skilled craftsmen whose techniques had been lost to time. But the engineers who actually examined these structures knew the explanation didn't hold. They had been trained to understand construction. They had studied every known method of bridge building, and what they found in the field matched none of it. The foundations presented the deepest mystery. Building a bridge foundation in a river requires cofferdams, massive temporary structures that hold back the water while workers dig into the riverbed. This process takes years. It requires hundreds of laborers, tons of materials, detailed planning, and constant maintenance against the pressure of the current. Yet many of the oldest bridges showed foundations sunk into riverbeds, with no historical record of cofferdams ever being built. No labor contracts survived. No material requisitions appeared in any archive. No newspaper accounts described the massive disruption such work would cause to river traffic and local commerce. One engineer in Belgium wrote that the foundation stones of a bridge he inspected extended at least 40 feet below the waterline. The stones were cut in precise rectangular blocks, each weighing several tons. How had they been lowered into position against the current? How had they been fitted together underwater with such accuracy that even after decades of submersion, no water penetrated the joints? He consulted every engineering text he could find. He interviewed the oldest workers in the region. No one could explain it. He concluded his report with a sentence that was later crossed out by an unknown hand. Either our understanding of construction is fundamentally incomplete, or these bridges were built by methods we no longer possess. The numbers repeated across counties, across countries, across continents. Spans that should have required steel achieved with stone alone. tolerances measured in fractions of millimeters on structures supposedly built with hand tools and human muscle, weight-bearing capacities that exceeded modern calculations by factors that seemed absurd. And always, the same silence in the records, the same absence of construction histories, the same missing archives where the documentation should have been. Some engineers began keeping private journals, separate from their official reports. In these journals, they wrote what they could not say publicly. One surveyor in Massachusetts described examining a bridge that local records dated to 1743. The stonework showed no weathering consistent with that age. The iron fittings showed no rust. The structure appeared almost new, yet multiple sources confirmed it had stood for over a century. "I am forced to consider," he wrote, "that either the records are wrong or my understanding of materials is wrong. I do not know which possibility disturbs me more." If the bridges were anomalies, the builders were ghosts. In old maps and municipal documents from the 1700s and early 1800s, researchers occasionally encounter a strange reference. The term appears in different forms across different languages, but the meaning seems consistent. The old builders, the builders before us, the ones who came before the current age of construction. In some documents, particularly those from Eastern European archives, another term appears: Tartarian. Tartarian engineers, Tartarian methods, Tartarian construction. This last term appears most often in Russian, German, and Austro-Hungarian records, though variations exist in French and even early American documents. The references are never explained in detail. They are mentioned in passing, as if the reader would already know what was meant. A bridge in Vienna is noted as restored following Tartarian design principles. A canal in Amsterdam is described as originally Tartarian construction, later modified for modern traffic. A railway bridge in upstate New York is logged as replacement for Tartarian span destroyed in flood of 1832. Modern historians dismiss these references as errors in translation, misattributed labels, or archaic terminology for ancient or foreign. The word Tartarian, they explain, was once used loosely to describe anything from the East, anything old, anything whose origins were unclear. It meant nothing specific. It was simply a placeholder for the unknown. But the consistency is troubling. The term appears in documents separated by thousands of miles and decades of time. It appears in official government records, not folklore collections or travelers' tales. And it appears specifically in connection with structures that exhibit the same impossible characteristics: precision beyond known technology, scale beyond documented capability, methods beyond recorded history. If the term meant nothing, why did so many unconnected sources use it in exactly the same way? More troubling still are the gaps in the census records. Building a major bridge requires workers, hundreds of them for the largest projects, sometimes thousands. These workers would need housing, food, wages, medical care. They would appear in tax rolls, in church registries, in hospital records, in court documents when disputes arose. Their presence would be documented in newspapers, in letters, in the daily business of the towns where they worked. A major construction project is not invisible. It cannot be invisible. Too many people are involved. Yet for many of the oldest and most anomalous bridges, these records do not exist. The bridges stand. The construction histories do not. Towns with bridges that should have required decades of labor show no population increase during the supposed construction period. No influx of workers from other regions. No temporary camps or boarding houses. No payroll disputes or workplace injuries. No marriages between local women and visiting laborers. Nothing. The bridges appeared, but the people who built them left no trace. Some researchers have suggested the bridges were built by military forces whose records were kept separate from civilian archives or deliberately destroyed for security reasons. Others propose that construction was completed by enslaved or conscripted labor, whose existence was deliberately obscured to avoid moral scrutiny. These explanations are possible. History is full of hidden labor, erased workers, convenient forgetting. But these explanations do not account for the technical anomalies. Even with unlimited labor, even with workers who left no records, The methods required to build these bridges remain unexplained. You cannot hide the techniques. You cannot erase the physics. The folklore takes a different approach. Across Eastern Europe, from Poland to the Urals, oral traditions describe a people who could build without scaffolding. Structures rose from the ground as if summoned by will alone. Bridges appeared over rivers where no construction had been observed by anyone in the surrounding villages. The stories speak of knowledge passed down through generations, techniques that required no written instructions because they were embedded in the work itself, in the hands that performed it, in the eyes that could see what needed to be done. The old builders did not teach through books. They did not write manuals or draw diagrams. They taught through doing, through demonstration, through a kind of transmission that modern education does not recognize. And when the last of them vanished, when the chain of direct teaching was broken, the knowledge vanished with them. You cannot learn from a book what was never written in a book. You cannot recover what was never recorded. Local historians in Poland, in Hungary, in the Czech lands, in the small villages of what was once the Austro-Hungarian Empire, recorded these stories in the 1800s. They were dismissed as peasant superstition by university scholars in Vienna and Berlin. But the peasants lived beside the bridges. They crossed them daily. They had watched their grandparents cross them and heard stories of great-grandparents doing the same. They remembered, in fragments, what the official histories had forgotten entirely. The official explanation fails quietly in the details that refuse to add up. If you study the engineering reports from the 1800s, if you read the surveyor's notes and the inspector's memoranda and the private correspondence between professionals who could not understand what they were seeing, a pattern emerges. The bridges were not built the way they should have been built. The timelines are wrong, the methods are wrong, the materials are wrong, and no one in authority seemed interested in investigating the discrepancies. Consider the timeline problem first. A major stone bridge requires years to complete under optimal conditions. The foundation work alone can take 2 or 3 years, sometimes longer if the river conditions are difficult. Cutting and transporting the stones requires active quarries, maintained roads, reliable shipping routes. Assembly requires scaffolding, cranes, and skilled masons working in careful sequence over many seasons. The largest bridges in history, built with modern equipment, experienced crews, and unlimited budgets, still take a decade or more from initial planning to final completion. This is not inefficiency. This is physics. This is the reality of moving heavy objects and fitting them together with precision. Yet municipal records from the 1800s describe bridges appearing in far shorter time frames. A bridge in Lyon was documented as complete in 1847, with no construction records prior to 1846. 14 months from nothing to a finished stone span crossing a major river. An iron bridge in Pittsburgh appeared in city maps in 1859. But engineering surveys from 1857 describe the site as undeveloped woodland with no infrastructure. A stone viaduct in Austria was photographed in 1862, fully complete and already carrying traffic, though the first permit application for bridge construction at that location was filed in 1861. These discrepancies were noted by contemporary observers. They were attributed to bureaucratic delays in recording, to lost paperwork, to informal construction that preceded official approval. The explanations were plausible enough to close the files. But the pattern is consistent across too many locations to be coincidence. The most impressive bridges, the ones with the most anomalous features, the ones that most defied engineering explanation, also had the shortest and least documented construction histories, as if they had appeared rather than been built, as if the records that should exist had never been created or had been removed before anyone thought to preserve them. The materials present another category of impossibility. Metallurgical analysis of iron components from 19th century bridges has revealed alloys that do not match known foundry outputs of the period. The iron contains trace elements, specific combinations of carbon and manganese and other metals, that were not commercially available in those proportions until decades after the bridges were supposedly built. The crystalline structure of the metal shows cooling rates that would require controlled environments far beyond period technology. The iron is too pure. It is too consistent. It was not made the way iron was made in the 1800s. Some analysts have proposed that the bridges incorporate salvaged materials from earlier structures, iron that was already old when it was reused. But this explanation creates more problems than it solves. Where did the original iron come from? What earlier structures produced metal of this quality? The questions multiply rather than resolve. The stone presents similar mysteries, perhaps even deeper ones. Granite blocks weighing 10 or 20 tons, cut with faces so mathematically flat that modern laser measurements find deviations of less than a millimeter across surfaces larger than a dining table. The cutting marks, where visible at all, do not match the patterns left by known 19th century tools. Some researchers have suggested the stones were cut with wire saws, a technology not commercially developed until the early 20th century. Others have proposed water jet cutting, or even controlled thermal fracturing using principles we still do not fully understand. None of these explanations fit the evidence completely. The stones were cut somehow. They were shaped with precision that modern equipment struggles to match. They were transported from quarries sometimes hundreds of miles away, across terrain with no documented roads or railways capable of bearing such weight. And they were assembled into structures that have outlasted everything we have built since. The how remains unanswered. The engineers who asked the questions were never given satisfactory answers. Eventually, most of them stopped asking. The question of how becomes harder to ignore when you see what happened next. Because the bridges didn't simply age. They didn't gradually fade from the landscape. They were removed, deliberately, systematically, with a thoroughness that feels, in retrospect, intentional. In the late 1800s and early 1900s, something shifted in how authorities viewed the old bridges. Structures that had stood for generations, that showed no signs of structural failure, that locals regarded as permanent fixtures of their landscape, began to be condemned. The reasons given were always practical, always reasonable. The bridge was too narrow for modern traffic. The materials were outdated and could not be certified under new safety standards. The design did not meet current engineering requirements. Progress required replacement. One by one, the old bridges came down. In their place rose new structures, built according to modern principles, documented thoroughly, certified by proper authorities. The old stone was carted away or broken into rubble for road fill. The old iron was melted down and recast into forms that met current specifications. The transition was presented as improvement. It was called progress, but the replacements told a different story. In city after city, the new bridges began failing within decades of their construction. Iron rusted faster than engineers had predicted. Concrete developed cracks that spread like disease through the structures. Foundations shifted in ways the calculations had not anticipated. The bridges that replaced the old builders' work required constant maintenance, repeated repairs, and eventual replacement themselves. A bridge built in 1890 to replace one from the 1700s might itself need replacement by 1950. The original had stood for 200 years without significant repair. Its successor lasted 60 years of constant maintenance before being declared unsafe. Progress, it seemed, moved backward. Each replacement was weaker than what it replaced. Each new bridge required more attention, more money, more intervention to keep standing. The old bridges had stood on their own. They had required nothing from the communities around them except crossing. The new bridges demanded constant care, like invalids requiring perpetual nursing. Contemporary newspapers occasionally noted the irony, though rarely with the alarm the situation deserved. An editorial in a Manchester paper from 1923 observed that the new iron bridge crossing the Irwell was already showing stress fractures in its supports, while the stone foundations of the bridge it replaced still stood solid beneath the water. Visible at low tide, apparently ready to support another bridge for another 2 centuries, if anyone cared to build one. We have gained speed and efficiency, the writer concluded, but we have lost something else. We have lost permanence. We have lost the ability to build things that last. The pattern extended across Europe and America. Old bridges were demolished and replaced with structures that proved inferior in almost every measurable respect. Weight capacity was often lower. Maintenance costs were dramatically higher. Expected lifespan was drastically shorter. The only advantage the new bridges offered was conformity with modern engineering standards. They were documented, they were certified, they matched the textbooks, and they fell apart. The targeting of the demolitions raises questions that no official source has adequately answered. The oldest bridges were demolished first, as if age alone made them suspect. The most anomalous bridges, the ones that most defied explanation, were prioritized for removal. Bridges in remote locations, bridges that faced no traffic pressure, bridges that showed no signs of wear, were declared unsafe and torn down. And in case after case, the records of the original construction vanished along with the structures themselves. Archives were lost to fires that struck with suspicious precision. Floods destroyed exactly the documents that would have explained the most puzzling structures. Administrative reorganizations moved records from one office to another until they disappeared entirely. Construction companies that won demolition contracts dissolved shortly after completing their work, their own records vanishing into the same void that had swallowed the bridge's histories. The process was not dramatic. It was not announced. It was quiet, methodical, bureaucratic, and remarkably thorough. When written records fail and institutional memories blur, one kind of evidence remains harder to dismiss. Photographs. The camera does not forget. The lens does not lie. And the surviving photographs from the 1800s tell a story that contradicts everything the official histories want us to believe. The images are haunting, not because of ghosts or supernatural shadows, but because of scale. A scale so immense it almost breaks the frame, challenges the eye, makes the viewer question whether what they are seeing can possibly be real. In one photograph from 1872, a group of engineers stands beside a bridge pillar somewhere in Pennsylvania. Their bodies are almost swallowed by its mass. The pillar rises behind them like a cliff face. Its stones fitted so tightly the joints are barely visible, even in the high-resolution scans made from the original glass plates. 8 men stand in a row, their arms outstretched, attempting to demonstrate the pillar's width. Together they barely span a quarter of its diameter. Their measuring equipment looks like toys against the structure they are attempting to document. Their faces show something that might be pride in their work or might be something closer to unease. Another photograph from the same era shows an iron span from below, taken by a photographer who positioned his camera in a small boat on the river. The supports curve overhead in an arc that seems to defy the weight they must be carrying. There are no visible bolts anywhere in the image, no visible welds, no rivets, no seams. The iron flows from one section to the next as if it had been poured in place and allowed to cool into this perfect, impossible shape. For scale, the photographer has included a horse-drawn cart crossing the bridge above. The cart, which would have seemed substantial standing next to it on the street, looks like something from a child's toy set. Then there are the images of bridges that no longer exist. These are perhaps the most valuable and the most disturbing. Photographs taken in the 1880s and 1890s showing structures that were demolished within years, sometimes months, of the pictures being made. Stone arches so wide that the photographer couldn't capture both ends in a single frame. Iron railings with decorative metalwork so intricate, so flowing, so organic in its patterns that modern metalworkers cannot explain how it was produced without computer-guided cutting tools. Foundations that extended below the waterline in perfect geometric precision, visible only because the photograph was taken during a drought that lowered the river to unusual levels. These photographs become a kind of unintentional confession. The photographers were not trying to document mysteries. They were civil servants and commercial operators recording bridges for municipal files, for engineering studies, for insurance assessments, for newspaper features about local landmarks. They had no agenda beyond documentation. They were not trying to capture evidence of lost technology. But evidence is exactly what they captured. Preserved in silver and glass, surviving when the structures themselves did not. In image after image, the scale of the old bridges dwarfs everything around them. The precision of the stonework exceeds anything the period could officially produce. The metalwork suggests techniques that were not supposed to exist. And the craftsmanship, visible in every joint and curve and carefully placed block, speaks of knowledge that did not come from the engineering schools of the 1800s. Knowledge that came from somewhere else, somewhere older, somewhere we can no longer access. Modern viewers sometimes assume these photographs must be manipulated, doctored, exaggerated through some trick of early camera technology. The scale seems wrong. The precision seems impossible. Our minds resist what our eyes are seeing. But photographic analysis confirms the images are authentic. The cameras match known models of the period. The development chemistry matches documented processes. The paper, the emulsion, the aging patterns all confirm the dates. And when analysts examine the proportions, measuring the known objects against the unknown structures, the calculations confirm what the eye suspects. The bridges really were that large. The craftsmanship really was that precise. And most of these structures, these impossible monuments to forgotten knowledge, no longer exist. The photographs of demolition are perhaps the most troubling of all. Images showing bridges being systematically dismantled by crews who seem almost confused by their own work. Stone blocks that were cut with impossible precision being smashed into rubble. Iron spans that showed no signs of wear or weakness being cut into sections and carted away for scrap. The expressions on the workers' faces often show something difficult to name. Not pride in a job well done. Not the satisfaction of progress. Something more like bewilderment. As if they too wondered why they were destroying something that had worked perfectly well for longer than anyone could remember. But the photographs only show what was built. The deeper mystery lies in how it was built, and in the knowledge that made such construction possible. Knowledge that seems to have existed, seems to have been real, and seems to have vanished so completely that we cannot even be certain what we have lost. Among engineers, historians, and independent researchers who have studied the old bridges seriously, there are recurring references to techniques that no modern method can replicate. These references appear in scattered sources across multiple languages and decades. Engineering journals from the 1850s mention methods their authors do not understand. Private correspondence between surveyors describes observations they cannot explain. Oral histories collected from elderly craftsmen in the early 1900s preserve fragments of knowledge that the craftsmen themselves could not fully articulate. The techniques are described but never explained. They are named but never demonstrated. They exist in the historical record like shadows of something that was once solid and real, and has since faded into darkness. The most persistent reference is to what some sources call resonant construction. The term appears in German engineering texts from the 1850s, in French technical manuals from the 1840s, in handwritten notes from American surveyors who examined the oldest bridges and struggled to understand how the stones held together without mortar, without clamps, without anything visible to bind them. Resonant construction appears to describe a method of fitting stones together using sound, using vibration, using some principle that connected the acoustic properties of materials to their physical placement. The details vary across sources, but the core concept remains consistent across documents that could not have influenced each other. The builders could tune stones to fit together by listening to them. A block placed correctly would produce one tone when struck. A block placed incorrectly would produce another. The builders could hear when the structure was right. They could feel it. The stone itself told them what they needed to know. Modern acousticians find this description intriguing but impossible to verify. Stone does produce resonant frequencies when struck. This is measurable, documented, scientifically uncontroversial. But using those frequencies to guide placement, to achieve sub-millimeter precision in fitting multi-ton blocks together, requires knowledge of acoustic physics that was not formally documented until well into the 20th century. Either the old builders developed this knowledge independently, through centuries of trial and error, leaving no written record of their discoveries, or they possessed techniques far older than our recorded history admits. Neither explanation is comfortable. Both require accepting that we have lost something we cannot recover. The metalwork presents mysteries equally deep. Analysis of iron components from the oldest bridges reveals alloys with properties that should not exist in materials produced before the 20th century. The iron is harder than period foundries could achieve. It resists corrosion better than modern steel in many cases. Its crystalline structure, visible under electron microscopes, suggests it was heated to temperatures and cooled at rates that 19th century equipment could not produce. Some researchers have proposed that the iron was made using methods similar to what we now call powder metallurgy. This is a process of compressing metal particles under extreme heat and pressure to create alloys with properties superior to conventional casting. But powder metallurgy was not developed commercially until the 1900s. The old builders, if they used this technique, were a century ahead of modern industry. And unlike modern industry, they left no patents, no papers, no documentation of their methods. Folklore from Eastern Europe offers its own explanations, dismissed by academics, but strangely consistent with the physical evidence. Stories collected in Poland and Hungary speak of smiths who could forge iron without fire. The metal would glow from being worked, heated by the force of the blows rather than by flames. The smiths could feel when the metal was ready to shape. They could hear the moment when the strike would have maximum effect. Their hands knew what their conscious minds did not need to understand. These stories were recorded by ethnographers in the late 1800s, classified as peasant fantasy, and filed away in university archives where they gathered dust for a century. But they describe something remarkably consistent with what the material analysis reveals. Iron worked in ways that do not match documented techniques. Metals shaped by methods that left no trace of conventional tools. Knowledge held in hands rather than books, transmitted through practice rather than instruction. Lost when the chain of transmission was broken. What replaced the old bridges tells its own story. A story of decline, a story of loss, a story that continues to unfold in headlines we have learned to ignore. By the mid-20th century, the era of infrastructure renewal was complete. The old bridges were gone, replaced by structures designed according to modern engineering principles, built with modern materials, documented with modern thoroughness. Steel and concrete had replaced stone and iron. Bolted connections had replaced seamless joints. Calculated lifespans had replaced apparent permanence. The new bridges were scientific, standardized, and supposedly superior in every way. They also began failing almost immediately. The collapse of the Silver Bridge in West Virginia in 1967 killed 46 people. Drivers plunged into the icy Ohio River without warning when the structure gave way during evening rush hour. Investigation revealed that a single eye-bar, a critical load-bearing component, had developed a stress crack that inspectors had missed during routine examinations. The crack grew until the metal failed. The failure cascaded through the structure. The bridge, built in 1928 to replace an older span, had stood for only 39 years. The structure it replaced, the one deemed inadequate for modern traffic, had stood for over a century with no recorded structural failures of any kind. This pattern has repeated across the decades. Bridges built in the early and mid-20th century to replace older structures have shown disturbing rates of deterioration. The I-35W Mississippi River Bridge collapsed in Minneapolis in 2007, killing 13 people and injuring many more. It had been built in 1967, 40 years from construction to catastrophic failure. Investigations found corrosion, metal fatigue, and design flaws that should have been identified during construction, but somehow were not. The bridge that had previously served that crossing, demolished to make way for the interstate highway system, had stood for nearly 100 years carrying traffic across the same river. The financial costs are staggering in their scope. The American Society of Civil Engineers estimates that the United States needs to spend over $100 billion simply to address bridges currently classified as structurally deficient. These are not ancient structures. These are bridges built within living memory, designed according to standards that were considered advanced at the time and already failing. The old bridges they replaced needed almost no maintenance at all. They stood for generations on their own. We cannot keep our bridges standing for decades, even with constant attention. Some engineers have begun asking uncomfortable questions in professional forums and private conversations. Why do our bridges fail so quickly compared to their predecessors? Why do they require such constant and expensive maintenance? Why? With all our computational power, our advanced materials, our sophisticated modeling software, can we not match the longevity of structures built with what we assume were primitive methods? The answers typically proposed are technical and unsatisfying. Modern bridges are optimized for specific loads and conditions, designed to use minimal materials while meeting safety standards. Older bridges were over-engineered by cautious builders who didn't trust their calculations, who built in margins of safety that seem wasteful by modern standards. Modern materials like reinforced concrete have inherent weaknesses, chemical and structural, that only become apparent over decades of exposure. Modern construction methods prioritize speed and cost efficiency over longevity, but these explanations feel incomplete. They assume the old bridges succeeded by accident, by excessive caution, by happy chance. They do not account for the precision of the stonework. They do not explain the mysterious alloys. They do not address the consistent patterns of excellence across structures built in different countries by supposedly unconnected builders. The old bridges were not lucky. Their builders knew something specific, something that worked, and we do not know what it was. The bridges were not simply structures. They were monuments to a kind of knowledge we no longer possess. Evidence of capabilities we cannot replicate. Proof that something existed, something was known, something was possible, that our current understanding cannot accommodate. The photographs document them. The engineering reports describe them. The material analyses confirm anomalies we cannot explain. The folklore remembers them in fragments that academia dismisses but cannot disprove. And the systematic failures of modern bridges, the collapses and closures and billion-dollar repair programs, demonstrate by contrast what has been lost. The old builders knew things we have forgotten. They could work stone with precision our best equipment struggles to match. They could forge iron with properties our metallurgists cannot reproduce. They could construct foundations that stood for centuries in riverbeds without maintenance. Spans that carried loads beyond our calculations, structures that became part of the landscape as if they had always been there, as if they belonged. We do not know who these builders were. The records call them Tartarian, or old builders, or simply the ones who came before. The references are fragmentary, scattered across archives that have been reorganized, damaged, relocated, and sometimes destroyed entirely. The consistent pattern of these disappearances may be coincidence. Bureaucratic incompetence is common enough in every era. Or it may be something more deliberate, something that prefers forgetting. What we know for certain is this: the bridges existed. The photographs prove their existence beyond any reasonable dispute. They were built with methods we cannot understand, using materials we cannot replicate, achieving results we cannot match. The physical evidence proves this. They lasted longer and performed better than anything we have built in the centuries since. The engineering data proves this as well. And they were systematically demolished, replaced with inferior structures that require constant maintenance and still fail, and erased from the professional discussions that should have preserved their memory. The historical record, fragmentary as it is, proves this too. The question that remains is not whether the old bridges were real. That question is answered. The question is what their existence implies about everything we think we know, about progress, about technology, about the confident assumption that we stand at the peak of human achievement and everything before us was primitive, fumbling, inferior. If the old builders possessed knowledge we have lost, then history is not a straight line rising upward toward the present. Something can be forgotten, techniques can vanish, capabilities can disappear, and the forgetting may not be accidental. Stand at the edge of a modern bridge. Feel it vibrate beneath the weight of passing vehicles. Watch the rust forming on supports that were new within your lifetime. And calculate how many years remain before this structure too must be replaced. Then imagine a bridge that stood for centuries, a bridge that needed no maintenance, no inspection, no repair, a bridge that the river accepted rather than fought, that the landscape embraced rather than resisted. A bridge built by people who knew things we do not know, using methods we cannot understand, leaving behind structures we could not replicate and chose instead to destroy. The giants of stone and iron are mostly gone now, demolished for progress, replaced with things that break. Their photographs remain in archives, evidence of something we prefer not to discuss. Their foundations sometimes remain as well, buried beneath new construction, ignored by the highways that pass overhead, waiting in darkness for someone to remember. The stones do not forget what they were part of. The iron does not forget how it was shaped. The rivers still flow where the old bridges stood, carrying water over foundations that were never fully removed because they proved too difficult to destroy. Only we forget. Only we choose not to remember. And the cost of that forgetting grows higher with every bridge that falls, every repair bill that comes due, every structure that fails to last as long as its builders promised. We have traded permanence for efficiency, excellence for standardization, knowledge for credentials. And we wonder why nothing we build endures. The old builders are gone. Their bridges are mostly gone. Their methods survive only in fragments too scattered to reassemble. But the evidence remains for anyone willing to look. The photographs, the material analyses, the engineering anomalies, the folklore that academics dismiss but cannot explain away. Something was known, something was lost. And until we admit that loss, until we stop pretending that progress only moves forward, we will keep building bridges that fall. The question of who the old builders were and what they knew refuses to stay buried. It waits, like the foundations beneath the highways, for someone to start digging.